There's no weight or heat disposal problems like you might have when you're burning gas to make power or other things like that. There's no noise pollution like you might have with certain power plants. Also, there's no transmission losses if you create your power on site. Now, let me talk about that a bit more in detail. Most power in our country is made from power plants that are located in a part of our state or country. Now, when that power is made, that has to be distributed to parts where the power plant is not located, and those are done by power lines. You've probably seen them as you're driving down the road. You might see them hanging off of these big iron structures. Now, those wires are transmitting the electricity made at the power plant to your house or to your place of business. But solar can be put directly on top of your house or directly on top of your business. And so there's no transmission losses involved if you have solar directly on your house. And transmission losses means when we make the power at the power plant, it doesn't go 100% to the end user. There's some loss of power along the way because the electricity loses its energy over a long distance. But not so with solar if you use it where you make it. If you have your solar panels on your roof and you use the power that you generate. So I'm going to move on now from why solar. And I'm going to talk a bit now about how a solar cell works. So what we're looking at here is in the orange box, this is a solar cell, and it's connected to a load. What is a load? A load can be anything. It can be a light bulb, it can be a computer, it can be a refrigerator, an air conditioner. But you have to connect the solar cell to that load through wires. Now, there has to be a wire to take the power to the device, like the light bulb, and there has to be a wire to take the power away. And so that's why I have two connections here, one from the top to the light bulb and coming back from the bottom to the bottom of the solar cell. So now let's talk about how this solar cell works. I hope everyone can see my animation. Now, what happens is light, when it shines on the solar cell, will produce electrons in an excited state. What does that mean? It means when the light shines onto the solar cell, it makes the electrons excited. They start to get up and walk around, and they run around inside the solar cell. But what's interesting about this, when the electron runs around inside the solar cell, it leaves behind something called a hole, which is actually positively charged. That's why I have an H there. The E minus is the electron, and the H plus is the hole. Now, I want you to imagine that you're digging inside a garden, and you have a shovel. When you go to pick up some dirt with your shovel, you pick up your dirt and you can see it in your shovel. And if you look down the ground, you're going to see a hole left behind where the dirt used to be. You can imagine that that's what's happening here. The electron is coming up out of its place inside the solar cell, and it leaves behind a hole. Now, what's funny is the electrons dance around, but the holes also dance around. They'll move around inside the solar cell as well. What's very important, though, is we have to separate these electrons and holes. If we don't, they're just going to come back together like putting the dirt back in the hole. But there's no power if all you do is pick up the dirt and put it back in the hole. The electron and the hole have to separate to the opposite sides of the device. And so solar cells are made to encourage this activity. The electron is attracted to the front and the hole is attracted to the back. And so what'll happen is the electron will travel in one direction through this circuit, and the hole will travel through the other direction. And when it goes through the circuit, it does work. And that work produces light in the case of this light bulb. Maybe I'll do that one more time. Well, let me see. I'm gonna go through this animation one more time so that everyone can see. So let's recap. How does a solar cell work? Light shines on our device, and it produces electrons dancing around inside the device, as well as holes. The holes are where the electrons used to be. They also dance around inside. But if we don't separate them, they will come back together and relax. They'll sit down and they'll go to sleep. But we want them to do work. And so we send them through our circuit. Electrons travel in one direction and the holes travel in the other to light our light bulb. Now let's move on. How do we make these electrons and holes separate? Here I'm showing you a diagram that illustrates the concept involved in producing power. So the electrons and holes are separated because when we have our solar cell body, we actually put positively charged atoms on one side and negatively charged atoms on the other. Excuse me, I'm doing that opposite. Negative charges over here and positive charges over here. Now, you might remember from basic electricity or magnetism that positive charges attract negative charges, right? If you have a magnet, if you put the north and south side together, they will stick, right? But if you put the north and north together or the south and south, it will be repelled. The same concept works here. The electrons want to go toward the positive charge, and the holes want to go toward the negative. And that's how a solar cell can be made to encourage this separation of the electrons and the holes to go into the circuit to do work. So I'm going to cover now just briefly how a solar cell can be made. I worked for many years on silicon solar cells, which is really the main solar cell made in the world. When you look on your roof or you see solar panels out on rooftops, it's usually made of silicon solar cells. And so what you have to do is first purify silicon. You could even go to the beach and dig up sand. Sand is made mostly with silicon and oxygen. And we'd have to melt that down and purify it into chunks. And we would melt those chunks and make big bricks. And then we would cut those big bricks into smaller bricks and wafers. Now, a silicon wafer is very thin. It's only 200 microns thick. It's almost like the thickness of a sheet of paper. And maybe the size of a sheet of paper in area as well, just to give you an idea. Now, that wafer itself cannot be made into a solar cell without first cleaning the surfaces. We have to make it very clean, and then we have to apply that thin layer of positive or negatively charged atoms to one side, and then we have to apply the positive or negative charges to the other side. So now we have our two sides, and we have to have metal contacts on there in order to draw out those holes and electrons. So that's basically how you make a solar cell. It's not as simple as I'm making it here, but certainly we don't have to go into the details. Now, why do we need solar cells? Where can they be used? Now here I'm just showing you a couple pictures of how, if you put solar to work, what will it do? Here is a solar panel where we've stitched together many solar cells to make more power than the one solar cell might make by itself. And you can imagine that we can use them to power cell phone towers, or if there is oil drilling out in the ocean, if they need power, they can use solar because it's hard to run electricity out to the middle of the ocean. You can also power certain devices inside your house, like refrigerators. If you go camping, you might be able to power a lantern by day to charge its battery so that it will shine at night. We can put solar panels on top of lights that you use for traffic signals. You can put them on the pumps to pump water, lots of different applications for solar, not just for powering rooftops. In addition, it can be used for mobility. Here I'm showing you an example of a car that has solar cells plastered onto the roof and onto the hood. Now I have to admit to you, solar is not mature enough right now to power a car by itself. Cars use a lot of electricity and a lot of power to run, and solar is just not ready for that yet. But maybe if you put solar on the car, it could help to cool it by running a fan when the car is not in use, if it sits in the sun, for instance. And I think eventually solar will be ready to power cars once we get an understanding of how to really use it efficiently. And finally, solar is used in space. This is an example of a satellite that has solar on these little wings. Now, you can't run electricity out into space, right? We can't make it here and pump it out there. We have to use the sun because the sun shines everywhere, not just on Earth, it shines in space. And so satellites use solar in order to power themselves. Now, at this point, this concludes my presentation. I believe there may be some time for some question and answer. And I have to admit, I don't know how I'm going to see your questions. So we'll just see how it goes. Robin, should I hand the presentation back to you?